Okay, here is another example. This one's maybe a little straightforward, does take a little bit of time, you know, to go through and compute a few of or actually the first part of this problem. And it's more of an issue of, can you work with a complex formula? Um, this type of problem here talks about monthly payments, total payments, and interest for a loan, and it's a amortized amortized loan, which is typical for say car payments, house payments, or mortgage payments, things of that nature. I know they're using a college, borrowing for college here, but a very common way of computing uh, you know interest and what it costs people, and typically we deal with monthly payments. And so to get into this, basically what we're going to be doing here is figuring out the monthly payment. I already used the solve button here. And just to show you, that's the number we got to get to, and how we need to be careful using these formulas. And we really don't need a formula here because once we find this payment, really all we have to do is multiply this number by the number of payments. So, if it's 12 a year times 20, I know it turns out to be 240. We're just taking this number times 240 to get this value. And you can see that it's kind of shocking here that borrowing 51,500, but over the 20 years, you're actually paying 83,000 back, 632, or whatever that is. Okay. And, to get that interest, all we do is we just subtract the 51,500 from the 83,632, and that's how much interest you pay. So you think about it, you're borrowing $51,000, you're paying all of that back in addition to an additional $32,000, which is well over 50% of what you even borrowed to begin with. So you can mess around with these formulas, and if you had them in a spreadsheet and change the number of years and so forth, and you'll see that the longer you borrow the money for, the more interest you pay. And the reason why people go out for longer is because it lowers the monthly payment. And that's kind of the game you get into. Like, ideally it's better to pay the higher monthly payment if you can afford to do so. Okay. Because then you're going to pay less money in the long run. But that's kind of how that works. So it's kind of shocking to find these values. So let's just, get into how they go about and get this payment right here. These two values are pretty straightforward, but so if I, first take a look at these formulas here, and if you want to dig through your Excel sheet, you can probably find this formula program somewhere, or you can just, make a new one in an Excel sheet, which might be a little bit easier. I'm just going to go ahead and use this calculator. I would not use the ALEKS calculator simply because this ALEKS calculator here doesn't have parentheses on there. So you can search on there. It's just not there. So I would probably not use that one. So anyway, to get into this one here, you just need to be careful. And I like, this because of the parentheses. So I'm going to take my numerator here, which is $51,500. All right. And hopefully I don't make any keying mistakes here. And I'm going to multiply that by the interest rate, which is 0.053. Okay. Remember, we have to have that expressed as a decimal, and that's how you convert 5.3% to a decimal. And of course, divided by 12, it's like the formula calls. So I close that parenthesis and I close off my numerator. And now I'm going to divide, and then I'll have another set of parentheses for my denominator, which is 1 minus. And then in parentheses, I have just 1 plus the interest rate. So I forgot the 1. So let me go back and change that. 1 plus the interest rate, which is 0.053 divided by 12. Okay. And then I'm going to close that parenthesis. Now remember, it's this quantity in parentheses, which is this. I now have to raise the negative 12 times. Remember, that's T is 20, right? Because that's the number of years. So I'm just going to type in here negative 240 because obviously there's a negative sign there, and 12 times 20 is 240. And then I need to come down and close that parenthesis off here. Okay. So when I do that, I should end up with my monthly payment. So let's see if I keyed in everything right. I apparently did. We get 348, and remember you have to round up. Okay, so I'm assuming Alex, being as forgiving as it is, not sarcastic, if you type in a 4.6 here, it's going to mark it wrong. So you need to be careful about that. Now, the other little tricky thing here, I guess, is some of the calculators, like if I say, okay, now I'm going to multiply that by 240 payments, you got to be careful here because it's using the rounded value. Now, this is kind of, this may get you upset. It says don't use any intermediate computations around your final answers, but I guess we're using that rounded final answer to calculate this value. And notice it's off here, not by much, just by 4 cents. But if you type that in, Alex, it's 76 instead of 80, it's going to mark it wrong. So what I needed to do is take the 348.47 and multiply that by 240. And there's my $83,632.80. And then, of course, I can take that value. Now, I can use my answer key in this case, right? Because that is the actual amount that I'm actually paying here. And I'm going to subtract now the 51,500. And there you go with your $32,132.80. Okay. So, again, these two solutions or two parts of the problem pretty easily done. You don't have to work with a formula or know any kind of fancy vocabulary. This one here, you obviously have to identify the proper formula to use. And like I said, you may want to dig up that spreadsheet. You still have it saved from, the discussion. I can't remember which question it was, or like I said, you can put some cells down, with these values in it, with a P and so forth, and type those numbers in, and then have one cell equals, and have cell references for all those, and then you can play around changing those values, and they'll constantly be updated. But that's up to you, for the monthly payment thing. So, okay, so that's it for that video, and I will probably get another one here for you here shortly. So, all right, see you next video.